Hello, we are live. Live for the KOG math homework help. And I am about to also go live on Facebook. Already set up. Hey, it's Latrell and we are live. I'm live. So, thank you all for coming so much. I got some new people to join the group, which is awesome. And I'm glad to have you all. So, I just gotta share into the group and then we're going to get started. Just give me 1 second. This is the KOG 5 math homework help. And I'm also live in my group. And I'm just sharing it in there. If you have any questions so far, just go ahead and drop it in the comment section and we can get started answering them after I actually answer the questions that some students already submitted, which is pretty awesome. We're going to talk about logarithms and z-scores. And if you are working with your child or your child had a question while they were doing homework tonight, some of you might have off of school, go ahead and share the question and we can answer that too. So I got one share. Anybody who's sharing, thank you so much also. About to get started in a few seconds. So I appreciate your patience. 2 people are watching. Awesome. Got a lot going on. I hear a whole bunch of notifications. What's up with my screen though? How does my screen look? If anybody's commenting, please tell me how my screen looks because it looks green to me right now. And okay, it went away. I'm watching on my other laptop. Okay. I just got some feedback. So anybody who has a question, go ahead and ask. And I would love for the people who asked me to answer questions to come and join. I see I got 2 views. Awesome. So if you are watching live, please go ahead and give me a wave or a heart or a like, a thumbs up or something. And we're going to get started with logarithms. This is for Samantha. So I'm going to just do this drawing right here. And you'll see why I'm doing this drawing in a second. I'm trying to do a good drawing, but it's looking kind of ugly. Okay, let's not do the nose. Let's just put a smiley face on. So this is a bunny because we're about to go over a way for you to help you to remember how to convert from exponents to logarithms and then back. So the little acronym that's being used is called Ben the Bunny. Ben the Bunny. Okay, so let's trace back. Logarithms. Logarithms are the inverse operation for exponential functions. So a logarithm is a function, and it is the opposite of an exponential function. Not exponent, but an exponential function. Just a little bit more. And I forgot the I here. And that's why we're able to go back and forth between logarithms and exponents. So we're going to use Ben the Bunny. And the reason why we're using Ben the Bunny is I'm going to write it out a different way. First, I'm going to use blue. So B is blue. E is red. And N is green. All right. So if you look at Ben, then the next word is B and E, or you can say Benny or Bunny. It's funner saying bunny. So when we write a exponent, an exponent equation, it will look like this. Where, well, first let me tell you what the variables or the letters stand for. So B stands for the base, and then E stands for the exponent, and then N stands for the number. Cool. All right, I'm gonna just use black because it would be hard for me to keep switching back and forth between the colors. But when we set up a exponential equation, it's gonna be the base raised to the e or exponent equal to n, the number. And then when we have a logarithm or a logarithmic equation, it's log, the base is b, then there's n, which is what it was equal to for the other equation, equals e, right? So the logarithm helps us to find out what the exponent is, and it's usually when the exponent is a variable like x. So we're gonna look some more into that. Okay, so this arrow shows that you can switch back and forth using Ben and Ben the Bunny acronym. Bunny the Ben or Ben the Bunny, whichever one you want to do. But you can see the order that the letters are presented in. B-E-N, that's the order you're going to write it in. You're going to spell Ben, B-E-N, and then you're going to spell bunny, but it's going to be B-N-E. B-N-E. Log sub B of N equals E, the exponent. Okay? Let me know if you have any questions on that. Whichever one you want to do. Oops, I'm sorry. Sorry for the sound. All right. Hey, Mara's here. Shayla came in. Hey, Miss Stacy. Julie came in. Thank you guys for hopping on. Okay. So let's look at some examples. Like I said, logarithms and exponential functions are inverses of each other. So I'm going to erase this. Ben the bunny. And I'm going to use blue. Blue for Ben. Okay. So looking at the exponential part first. Let's say we have 2. 2 is the base. To the third power or exponent. 2 to the third power, what's that? It's 8. 2 to the third is 8. Okay. We can write this as a logarithmic equation using bunny. Here's Ben. Oops. Ben. And now we're going to write it as bunny. So log, the base is 2. The n is the number 8. So we're going to write 8 here. And the exponent is 3. Remember, we're trying to find the exponent when we're using logarithms. So that's how you convert. Let's do it again. Also, one more thing. If ever you see a log and you don't see a base, the base is 10. Because logs are written in base 10. All right, just wanted to point that out. So let's say we got 5 to the third power equals 125. Yes, it does. I'm going to go down. We want to write that as a logarithm, a logarithmic equation, or write it in logarithmic form, however you may see it on your assignment or test. So this has been, we want to write it as bunny. So remember, log, the base is 5, goes down here. N is actually 125, and then E is 3. So the log base 5 of 125 is 3. That's the exponent. One more, and then we're going to do the other way. We're going to reverse it. Go start with logs, and actually, we got some examples. Let's do all of these, because all of these are probably on your homework assignment. And then we'll go to logarithms to exponents. So we got 7 to the negative 4th power equals 1 over 2401. Okay, cool. That's in Ben form. We want to write it in log form or bunny form. So we got the log, the base is 7. The number is 1 over 2401, and the exponent is negative 4. Exactly how it's written, whatever number relates to that variable or that letter, you're going to write it in the bunny form in the logarithmic equation. Uno más, so one more, then we're going to do it the other way. By the way, if you're having trouble seeing or hearing, let me know. Thank you for all the people who jumped on too. Okay, so let's say we got the cubed root of 2197 equals 13. All right, so this equation is not particularly in exponential form, but there is a rule that says if you have the square root of a number, where or not even the square root, if you have a root of a number, nth root, I'll say that, nth root of a number, you can rewrite it as x to the a over n. So whatever the exponent is on the inside, that goes in the numerator of the new exponent, and whatever the index or that number on the outside part of the root is that goes in the denominator of the new exponent. So following this, let me circle that as a little note. So following this rule, we want to convert this cubed root of 2197 to be an exponent. We want it to be an exponent and not a cube root. So it's 2197. And what's the exponent of 2197 under the radical? Well, I don't see an exponent. So that automatically means that the exponent is 1. We call that invisible math. So awesome. Okay, so like I said before in the note, the a, which is the exponent inside, goes in the numerator of the new exponent. So our exponent inside is 1, and the index on the outside goes in the denominator. So this is 2197 to the 1/3 power, still equals 13. Okay, cool. Now we want to go ahead and write it as a logarithmic form. So this is in Ben form. We want to write it in bunny form. Okay, so we start with log. Our b, or our base, is 2197. Our n, or our number, is 13, and the exponent is 1/3. There you go. Ben the bunny. Ben the bunny. That's the Ben the bunny way. So Ben the bunny way is exponential form to logarithmic form. Now, if you want to go the opposite, which would be bunny the Ben way, bunny the Ben, that is logarithmic to exponential form. So I'll use a different color for that. Also, guys, don't forget to share. If you know someone who needs help or who can benefit from this, please share out to your friends and fam, or tag someone to add them to the video. I'll use magenta. Okay, so now we're starting with logarithmic form. Bunny the Ben, we're going backwards. Okay, so let's say we got a logarithmic equation that has base 3, n is number 81, and equal to 4, which is the exponent. So that's bunny form. We're going to Ben form, bunny the Ben. So let's remind ourselves, Ben, remember we got b to the b to the e equals n. So what's our base? Our base is 3. So remember, bunny, whichever number is first is the b when we read from left to right for the logarithmic equation. So b is actually 3. N is 8. So that goes in the side. And then the exponent is 8, and then the exponent is second. No, yes, the exponent is the logarithmic equation, which is last, and then the exponent is second in the exponential equation. So the second number is the last number is, and it's not 81. Hey, Mr. Martin, for joining. Do another one because this one was a little busy. Is 81. We're doing log sub 2 1/2 equals above. Okay. Then E is 2. E is the last one in bunny, so the last number in bunny is -8. And then N, which is what it's equal to, is actually the second number in bunny, so that is 1 over 256. 2 to the -8th power is 1 over 256. And if we convert 2 to the negative power to the proper way to write it, which would be 1 over 2 to the 8th, that would even better identify with the answer. And all we have to do is find the exponential, find the power of 2 to the 8th power. Find the answer to 2 to the 8th power. Forgot that I have people on YouTube as well on my website. Any questions so far? And Mara, I did not forget about you. We are still going to be going over z-score. Okay, so let's do one more. And then we're pretty much done with converting logs to exponents and vice versa. Excuse me. One second, please. All right, I'm just checking questions. I didn't see any questions anywhere else, so I'm going to continue on. Just wanted to make sure. All right, one more. So we got log 0.001 equals -3. Okay, so hey person who just jumped on. So I don't see a base in this equation, this logarithmic equation. So like I said before, when you don't see a base, that means that the base is 10. 0.001 equals -3. Okay, so this is bunny form. Our B is 10. Should have been doing this the whole time. Do this. Label your variables these aren't variables, but label your numbers when you're doing this so that you can go ahead and just plug it into the exponential equation when it's time to do that. So B is 10, N equals 0.001, and E equals -3. Okay, so we want to put our equation in Ben form, from bunny form, and all we need to do is look at what the letters are equal to and plug it in. So B was 10, E is -3, and N is 0.001. And there you go. Not too bad at all. Not too shabby. Not too shabby. Any other questions, anyone? That's just converting back and forth between logarithmic and exponential form. Let's do just a quick example of how to evaluate logarithmic equations. So here's one that says log base 2 of 64 equals x, right? So we don't know what the exponent is, but we're trying to figure it out. So what this is saying is what 2 raised to what power will give us 64? Because remember, this is in bunny form. Bunny form means the base is 2. The base is the number that's being exponentiated. N is x. We don't know what the number, what the answer is going to be. N is also answer. And then E is the exponent. Oh, sorry. Uh, N is 64. So we do know what um, the answer is. We don't know what the exponent is, which is x. Go from left to right. Okay. So we want to write this in bin form. The base is 2 raised to the exponent, we don't know. And the n is 64. Okay. So what number what number is the exponent? Well, if you know that 2 to the 6th is 64, all you need to do is set the exponents equal to each other, and it'll be x equals 6. So 2 to the 6 equals 2 to the 6, and you're done. Questions, anyone? Apologize for the little bits of confusion. I haven't done logarithms in a while, and I just looked over some notes for it. So let's go to z-score. Logarithms and exponential functions were fun. Nice to meet you, Ben the Bunny. And we're going to keep you for when we need you on a test and for our homework. But we're moving on. I guess I could have saved this screen. I should have. I didn't. I feel like the professor that erases the board too fast. All right, we're still here till 9. Now we're going to talk about z-score, which is some good old statistics. So I don't know if you've seen this before, but there's this thing called normal distribution. And this is the bell curve, which represents the distribution of some things, some values, right? I always draw the bell curve wrong, but it is what it is. So down the middle gives us the mean, which is the average score that most people got. The average score, the average number that shows up in a sample or in a population of stuff. So let's say we're talking about test scores in the class. So mu, which is this number, it's a Greek number, Greek letter, which represents a number that we don't know. So this is called mu. And then this under it is called x bar. They represent the same thing depending on what you're talking about, what kind of sample you have. Then, so there's something called the standard deviation. The standard deviation for the mean would be 0 because the standard deviation tells how far away the number that you're talking about is from the mean. So sometimes you may pull a number out of a sample of numbers or out of a collection of numbers, and it's not what the average number is. It could be a little bit above it or a little bit below it. But the reason why this hump is here is because it's basically like filled up with a bunch of the same number. So let's say this is 0 and this is 100%. 50% is right in the middle. So if 50% was the mean or the average, then that means that it's right in the middle. Sometimes it's skewed. I'm sure you've heard of that too, where it looks like that, or skewed to the left, where it looks like that, where the this means that the mean is close to the beginning of that sample, or when you put all the numbers in order from least to greatest, the mean is close to the beginning of those numbers. And when it looks like this, and that means that the mean is close to the end of those numbers. So if we're talking about scores in a class, it means the first one would mean if it was like from 0 to 100, so 100 questions on the test. And the mean would be how many people got the numbers. Sorry, the numbers will be how many each student got right. Okay, so based on the first normal distribution curve, it looks like most of the students got a higher amount of the questions right than this normal distribution curve, where they got a small amount of the questions right. So let's say they got 15 questions right, and this one they got 85 questions right. So that's what that means when you see that like that. But for the one that we're looking at, that we're working on, this shows that I'm choosing 50. Most people got 50 questions right on this test. That's why it's called the mean, the average. Hey, Mom. Thanks for jumping on. Okay. So the further we go out from the mean, creates a deviation between the mean and the new number. And this will be called the standard deviation, what we're about to draw, because it's a standard. It's always going to be the same. Well, it's not always going to be the same, but it's going to be the same for each time you go out from the mean. So this one would be u minus or plus s, because it's in front of the mean. So s is the sample, and then if we go behind the mean, it would be mu minus s. Sorry, s is standard deviation. What am I talking about? S is standard deviation, and then I actually think this is supposed to be x minus s. Statistics is not 100% my thing either, but I had to learn it, and this is something that you can do too. You don't have to just say, oh, I don't know that, I don't get it, so I'm just gonna not know how to do it and ignore it. So mu plus sigma. Sigma is standard deviation, and then mu minus sigma. And then for x bar, which will be the different type of information, it will be x bar minus s, which is the standard deviation, just like Roman letters. Yeah. And then the other letters were Greek letters. I don't know why they have to use different letters. And then x bar plus s. So the difference between these two are 68%. 68% is in between. 68% of the people who got around the mean. So this is exactly the mean. And excuse me. Hey Jabbar. All this space in here is like around the mean. So if the mean is 50, then a large amount of people got 55 right, and a large amount of people got 45 right, because that's minus. If my standard deviation is is 5. My standard deviation is 5. That means it would go up 5 and down 5. Okay, I'm just going to draw the other ones. The distance between these two, new color, would be 95. The distance between these two, I wrote down 95 twice. I think it's 98. Is 98%. And then the distance between all the way super duper close to either a perfect score or a 0 is 99.7%. Okay, if you've taken statistics, which most people do take statistics when they go to college, I'm sure you've seen this. So now let's talk about the z-score. So the z-score basically converts the regular scores, or the regular numbers that we have in our data. It converts it to or standardizes it. So it converts it to smaller numbers, where the mean is actually 0, and then anything above or below that, this would be -1, this would be 1, and this would be -2, and this would be 2. Okay, so it's not these numbers that you're using the sigma for, which is standard deviation. Okay, I'm reading notes because I had to learn this to teach it to you guys, to Mara in particular. So it says my notes say the z-scores or standard scores standardize the scores. Okay, scores meaning numbers in our data. Sorry about the dog barking. It tells how many standard deviations above or below the value is from the mean. Remember, the mean is mu or x bar. Positive z-scores mean that it's above the mean. So that's these numbers over here. And negative standard z-scores mean that the z-score is below the mean. All right. The mean for a distribution has a z-score of 0 if because it's the mean. So the mean is 0 because it doesn't go above or below itself. It is itself. Whew. Okay. So let's do some exercises on this situation. So this is the z-score distribution. Trying to see if I should do it with this little bit of room, but I think I can. new color, blue. All right, so thank you for everyone who hopped on. Excuse me. Thank you for everyone who shared. Appreciate it. I really do, and I hope it's helpful for one of you, some of you. Appreciate it. Okay, so we have a situation, and the situation is that Jimmy took a test, right? Jimmy, his score was 43 out of 50. That was his score. So that means that the total amount of questions on the test, let me just label it right now. Total questions, and this is number of questions he got right or that were correct. All right, cool. So Jimmy got a 43 out of 50. Not that bad. Just got 7 wrong out of 50. I know he was in there for a long time taking that test. Bixby always trying to pick up my voice and answer my questions, but that I don't have. The standard deviation is 6. So sigma is 6, standard deviation. And the mu, or the mean, is 35. The mean is the average number of questions that were correct on average number student on the average number of students tests. I want to say that right. Mean number right in the class. The mean or the average number of right questions in the class. Let's write that. Average number of correct in class. Cool. All right. So let's set up a normal distribution real quick. Okay. So the mean is in the middle. And actually it doesn't even look like this because if the mean if oh yeah, never mind. There were 50 questions on the test. So it doesn't look like what I just drew. It's actually skewed to the right because there's 50 on the test, 0 in the back, and then 35 was the mean. So 35 is very close to it's 15 away from 50. So I probably should have drawn it more skewed to the right. But this is okay for now. And so that's the mean. So that's mu. And Jimmy, got 43 right. 35 is what is the average amount of questions correct in the class, and 43 is what Jimmy got on his test. He got 43 right on his test, so he got above average. That's one observation. He got above average. So we want to find out what the z-score is of Jimmy's grade. So the z-score equation or formula is x minus mu, or the mean, over sigma. That's the equation. We're going to use this to find out Jimmy's z-score. It's going to be so quick and easy. So just going to put Z for short. X is the actual score or the number. The number is 43. 43 minus mu is 35. Well, mu is 35. 43 minus 35 now over sigma, which is 6, the standard deviation. So 43 minus 35 is, let me do it in my head. So 43 minus 30 is 13. Yes. And 13 minus 5 is 8. Doubt myself. Right? And then 13 minus 5 is 8. Yeah. So 8 over 6. 8 over 6 is, we can reduce that fraction to 4 thirds. And I forgot what 4 thirds is as a decimal. 1.333. So that's the answer. 1.33. I think z-scores only go out to 2 decimal places. Actually, I think they go out further. But either way, it's just going to be threes. The threes repeat. So there you go. That's the z-score. Bottom corner. Z-score. Whew. Any questions? Anyone? Mara, this is for you. I'm going to do one more, then we out. And remember we said that the z-score would be positive if it was above the mean. Well, the mean is 0 on our z-score scale. The mean is 0. And actually, in real life or normal distribution, the mean is actually 35. All the numbers in front of 0 are positive, all the numbers behind 0 are negative, and our z-score says 1.33. So that means that we were right when we said that it matches up when we said that he scored above average compared to the rest of the class. Yay. Okay, let's do another one similar to this, just to get some practice in. I'm going to take a picture of this. I should have took a picture of the other one and send it to Samantha, but I'll just write it up again. Or Samantha, you can just watch it and take notes. So this is, oops, sorry, Z score for Mara. But you say your name was Miyoshi. I'm gonna just save it like that there. And then I'll do my last one. Actually, let me keep some of these, these words, because all I'm doing is changing numbers. Okay, so we're gonna talk about Kristen now. Kristen took a test too, and thought I was grabbing the right color, the same color, but I didn't. Um, I'm gonna get a different color. I'm gonna get this red. So, oh yeah, and we're not talking about Jimmy. We're talking about Kristen. Okay, so Kristen She took a test too, but she was in a different class, and her score was an 87 out of 100. She did pretty good as well. Good job, Kristen. Okay, and the sigma, or standard deviation, was 10, and the mu was 75. So the mean was 75. Standard deviation, I'm still like a little fuzzy on it. I think it's the amount out from the it is the deviation from the mean, the standard deviation from the mean. I don't know why 10 was chosen. I do know that 10 was given, and I know where to plug it in at. I just got to look up um, how 10 was produced, or where 10 came from as the standard deviation. Just wanted to be honest about that. Okay. So 100 was the total amount of questions on the test, and then 87 is the amount of questions that she got right for the distribution. So the mu, or the average, was 75. So 75 is the average amount of questions that students got correct on their test. So what is 75 compared to 100? And what is 75 compared to half of 100? Half of 100 is 50. And remember, 100 is the total amount of questions. Half of 100 is 50, and 75 is above um, 50. Actually, it's right in between 50 and 100. So this line skews to the right again. I mean, not line, but this distribution skews to the right again. Ooh, that wasn't that bad. Okay, so here's 100. Here's 0. And here's the mean, 75. It's crazy because 50 would be right there. Or somewhere, or somewhere else. Anyway, um, we got our equation. We got we got our what our variables stand for, and all we need to do is just plug in. So the z score equals x minus, x is the actual score, or the numbers that we are focused on, minus mu divided by sigma. So x minus the mean divided by the standard deviation. Our x is 87, minus the mean is 75, divided by the standard deviation is 10. Okie dokie. 87 minus 75 is 7 minus 5 is 2, 8 minus 7 is 1, over 10. And then we do that division, would be 1.2. Yay! So once again, um, Kristen got an 87. So she scored above the average. She scored above average um, of the class score. And so her Z score is positive, which shows that um, her score was above average as well. Both of those match up. That means we did the question. That's an indicator that the question is right. I mean that the answer is right. And we're done. Yay! Any more questions? It took me a whole hour to do both of these, but that's cool. Somebody learned something. And if you know somebody who comes up with who needs answers to these type of questions in the future, you can refer them to this video. I will put in the description. Well, I think I already put in the description what I was talking about in this video. But if you have any questions later on and you're watching, or if I made a mistake, let me know. I don't mind going back and fixing it in a new video, because we're imperfect, we're human, and we all make mistakes. So I appreciate once again everybody for joining, watching, sharing, um, commenting. I see Messy Mars said hello, hello. Thank you for joining in, and I hope that I answered your question on z-scores and standard deviation and normal distribution in a way that you can understand. Like I said, it was not the strong. I wasn't the strongest in it, but um, I studied, and I'm going to study some more because I want to also offer statistics as something that I tutor, a subject that I'm able to tutor. So it's in the works. I had to help my cousin with this recently, and I kind of learned it as I was helping her at the same time, and it wasn't that bad. Just got to get stronger in it and understand my whys, because when you know why something works the way it does, like I still need to understand the standard deviation portion and why that is, what it means, and how it came about. Um, we understand why everything goes together so smoothly. And Samantha, remember, Ben the bunny, Ben the BNE. All right, I'm out. Also, I made a new guide today, and it's called "You Need This to Do That in Algebra." You need this to do that in algebra. So I have like I think about 6 or 7 popular math concepts that you usually learn in algebra class or algebra 2, and I have that in the second column. And in the first column, I tell you what you need. So you need to know how to do operations on fractions, do operations on integers. Um, you need to know how to thank you for coming to join on YouTube. I see you. You need to know how to you need to know the multiplicative identity property. You need to know the distributive property. You need to know how to plot points. You need to know all these little things to do the bigger things, and that's really important. When you get to the bigger things and your basic skills are weak, it's hard for you to move on. It's because you got to like kind of relearn everything. With rational equations, you got to know least common multiple, which would be the same thing as least common denominator, so that you can get the denominators the same, because rational equations are just fractions being added to fractions equal to a fraction or a whole number, but sometimes the fractions have like x minus 2 as the denominator. You know what I'm saying? Or there's an x in the numerator. So having the basic understandings of um, the basic concept helps you to understand the more complex version of that. So that's the guide. It's called "You Need This to Do That in Algebra," and you can download it in the description of this video. And I hope you enjoy it. If you have any more things you want me to add to, or you want to make me another one, because I'm going to make more. That was just like one I wanted to put together. But I know that there are more concepts that can be added to that. So if you have a request for what you should know to be able to do a more complex um, algebra concept, let me know. Leave it in the description of this video, or email me back after I email you the form or the guide after you sign up and everything. All right. Thank you for everybody who joined my group today. I got like 7 new members this week, which is pretty awesome. Join my group KOG Math Achievers Club. We in there achieving some math, and we're gonna have a lot of fun. We're gonna get some help and pass our class this semester. All right. Have a good night, everyone. Bye bye.